Hey, research method students. I hope you're doing well today. It is a really nice, although incredibly warm day. I am recording this on April 8th. So I hope you're all doing well and taking good care of yourselves. So today and for this week, we're going to talk about validity. In particular, we're going to spend a lot of time talking about that internal validity that we want, being able to draw good cause-effect relationships in our experiments. And we're going to talk about experimental control. I think you're really going to like this section. This is the infamous lecture where I rag on Your Baby Can Read. So hopefully you have something to really look forward to in this lecture. But before we begin, I do want to start with a few reminders. So first of all, your 0-point method section draft is due April 16th. Now, I still haven't gotten all of the responses to the doodle poll that I wanted for peer review. It looks like some of you are in favor for keeping peer review. Some of you are not wanting peer review. Here's what I'm going to go ahead and recommend for this 0-point draft. Go ahead and send it to me, and I will give you 3 big things that I want you to work on for next time. If at that point you would like to get some additional peer review, it is not required, but I think it's a good idea to try to do in addition to getting feedback from me. Homework 8 is going to be due the following day, Friday, April 17th. You either need to email me or upload the file to eLearning, and it's pretty simple. All you have to do is identify the steps that you are going to take to improve your next draft of the method section, which will be due, if I am not mistaken, around the last week of classes or during what would have been finals week. Quiz 8 is going to post April 17th, and it will be due the following Friday on April 24th, and that due date is 11:59 p.m. Central Standard Time. Okay. So here's what we're going to cover in this lecture. So we're going to talk about threats to internal validity. Now, the reason that you would want to do an experiment is because you want to find a cause-effect relationship of some kind. So if you have potential confounding variables that could damage that cause-effect relationship, we need to figure out the best way to reduce these threats. So we're largely going to be focusing on internal validity because, well, it's part of the reason why we're doing an experiment. We want that causal claim, and we really don't want to dampen that causal claim. So we're going to talk about some different ways to reduce threats to validity or confounds, and then we'll finally talk about how you can interpret findings in which you find no statistical effect, or what are better known as null findings. So what do you do when you don't get an effect? How should you interpret it? So we're going to start by talking about our threats to internal validity. So I'm going to talk about 3 really bad experiments that come from your textbook. So I'm going to read each of these in a little bit more detail directly from your book, and you can kind of see that I've summarized them for you on this slide. So the first one, Nikhil, a summer camp counselor and psychology major, has noticed that his current cabin of 15 boys is an especially rowdy bunch. He's heard a change in diet might help them calm down, so he eliminates the sugary snacks and desserts from their meals for 2 days. As he expected, the boys are much quieter and calmer by the end of the week, after refined sugar has been eliminated from their diets. So that's the first one. Will a low-sugar diet reduce rowdy behavior? The second experiment, or supposed experiment, Dr. Yuki has recruited a sample of 40 depressed women, all of whom are interested in receiving psychotherapy to treat their depression. She measures their level of depression using a standard depression inventory at the start of therapy. For 12 weeks, all the women participate in Dr. Yuki's style of cognitive therapy. At the end of the 12-week session, she measures the women again and finds that on the whole, their levels of depression have significantly decreased. And then finally, the final study, a dormitory on a university campus has started a Go Green Facebook campaign focused on persuading students to turn out the lights in their rooms when they're not needed. Dorm residents receive emails and messages on Facebook that encourage energy-saving behaviors. At the start of the campaign, the head resident noted how many kilowatt hours the dorm was using by checking the electric meters on the building. At the end of the 2-month campaign, the head resident checks the meters again and finds that the usage has dropped. He compares the two measures, pre-test and post-test, and finds that they are significantly different. So your book notes that these are all really bad experiments. Now, all of these are instances where a change has been noted from the beginning, before the intervention was introduced, whether that's a low-sugar diet, a therapeutic treatment, or a Facebook campaign, and then seeing a reflection of that intervention in changed behavior. However, I hope that you notice that there's a huge problem here. All of these studies have no comparison group. All of these studies are basically a one-group pre-test, post-test design. So basically, a one-group pre-test, post-test design looks like this. So we have our participants. We do a pre-test measure, our dependent variable. We do a particular treatment, which we're treating as an independent variable, and then a post-test measure, or our second dependent variable. So we're going to look for a change between pre-test and post-test. So in the case of the camping study, we have our campers, we measure rowdy behavior, we reduce sugar, we measure rowdy behavior again. With our depressed women, we measure their depression, we give them a therapy, and then we measure their depression again. One of the problems is that none of these have a sufficient comparison group. And this is going to be a really big problem for the conclusions that are drawn. So let's talk a little bit more about why these studies are bad. Now, let's talk about the importance of internal validity. Now, if you're doing an experiment, you are ultimately planning on some kind of causal relationship. So this means that it's important to ensure that your internal validity is not poor. And so we're going to spend some time talking about different threats to validity. We're going to talk about 7 different ways that your data can be confounded. So really quick, going back, for example, to our campers. They have rowdy behavior, we reduce their sugar, and then we measure their rowdy behavior again. Part of the problem is that we have no idea if it was, in fact, the sugar that changed that behavior. This behavior could have changed on its own. And because it could have changed on its own, which we'll talk about very soon, it's really important to have a comparison group. My first instinct as a researcher is to have a comparison group that gets both the measures of rowdy behavior, but no intervention. If we see that there's a difference between our group that is getting the low sugar diet and the group that is not getting any intervention, if there's a difference between the two, we'll know that it's our diet that worked. But we need to have that good comparison group in place to ensure that it is, in fact, our intervention that had the effect and not something else. And when you don't have a comparison group, you really can't make the claim that this caused a change in rowdy behavior. So here are the 7 threats to internal validity. And we're going to talk about each of these in turn. And your book is largely going to focus on the first 6 because each of these could play a role in a one group pre-test, post-test design. But let's be very clear, all of these are possible within any sort of experiment that you do. And we're going to spend more time talking about each of these, but they are history, maturation, testing, instrumentation, regression to the mean, or what your book calls a regression threat, attrition, and selection. Now, some designs are going to be more vulnerable to these threats. And as I kind of mentioned, this bad experiment, one group pre-test, post-test design are going to be especially vulnerable to 6 of these: history, maturation, regression, attrition, testing, and instrumentation. And we'll talk about why some of these are, would be especially critical and potential threats in these kind of designs. So we're going to start by talking about history and maturation. History and maturation are basically when either a particular event or a particular time is basically being treated as your confound. So history is basically an event that occurs when the study is conducted. Now, what's really critical is that these events are not part of the experiment or in the treatment. So, for example, your book talks about this a little bit. One of the things that I think is kind of interesting with the Go Green Facebook campaign is that the campaign in this bad study starts at the beginning of the semester and it ends at the end of the semester. That is basically 4 months. A semester, give or take, is about 4 or 5 months. And a lot of things happen weather-wise and daylight-wise in a period of about 5 months. So, for example, perhaps this Go Green Facebook campaign was basically started in the winter time when it's dark outside for a longer period of time and it's darker earlier and you have the lights on more often, and it ends in the spring semester after a time change where you probably don't have to turn on the lights until about 7 or 8 o'clock at night. So this is something that the change in season could potentially explain why we see that reduction in electrical usage. And it might have nothing to do with our intervention at all. It's part of the reason why a comparison group is really critical. Now, another example could be something like economic improvement. So, for example, let's say with our depression study, during the time period that these depressed women are receiving treatment, maybe the economy rebounds and people are more able to find work. People tend to feel better about their job prospects. People feel a lot more willing to go out and engage in consumer spending, and that might make people feel less depressed. So that has nothing to do with the therapy itself. It's just something that's going on that could potentially contribute to a less depressed mood. So we have to kind of keep that in mind. Maturation is basically the ways that people change naturally over time. And these changes are independent of the study. This can include things like age-related changes, time of day effects. For young adults, we know, for example, that if I gave you an experiment really early in the morning, you'd do really badly at it. Not for any other reason than young adults tend to be at their absolute cognitive best and also best in terms of their energy levels in the afternoon. So generally, you want to try to find a time to do an experiment when people are at their best, not at their worst. Don't run your experiments at 5 o'clock in the morning. I will not show up, and I will be tired, and I will not do well. Recovery from illness could be a form of maturation. Increases in knowledge could be a form of maturation. And one of the other things that I'll mention in the case of our depression study, there are instances where spontaneous remission does happen. So sometimes people who are struggling with depression will have spontaneous remission without any sort of intervention at all. And because spontaneous remission is absolutely possible, we have no idea if it's our intervention that worked or if it's simply because this is something that happens over time. So yeah, in depression studies, spontaneous remission is possible. So we need to be able to tease apart the effects of the treatment, our intervention, and other confounds. So how do we do this? One of the things that we can absolutely do is, for both history and maturation effects, have a comparison group. So here's a case where we are looking at our Go Green campaign, and we do actually have a comparison group. So our green line is our Go Green campaign. Here is our group that did not get the campaign. Now notice if we get data that looks like this, so we see that kilowatt hours is high in September but decreases by November. This is basically saying that this is possibly a history effect. So in September, you're probably using more air conditioning, which is a huge energy thief. And in November, you're using less. So in this case, because there's no difference between my groups, I know my intervention is not effective. It's because of the passage of time. If, on the other hand, I have a comparison group and I find that the group with no campaign still has slightly higher usage in November than my Go Green campaign, I will know that this is because my intervention worked. So it's really critical to have a comparison group so you can figure out if your results are due to changes over time or if it's because your intervention actually is doing something. Next, we're going to talk about the regression to the mean. You may have heard of this as the law of averages. So generally, when two variables aren't perfectly correlated with each other, and let's be completely honest, most variables are not perfectly correlated, we're going to find that values will tend to regress toward the average. So generally, we will tend to find that if you're high in one variable, you're going to temporarily be low in the other one, but you do have an average level that you will typically find yourself in. So for example, for the most part, unless you study really, really hard, I've often tended to find that if you get a 100 on an exam, your next exam may not necessarily be a 100. It might be a little bit lower because of that regression to the mean. Likewise, let's think about coin flips, for example. Now, I want you to imagine that you keep flipping heads over and over and over and over again. Eventually, you are probably going to get a lot of tails up flips after a while. And that's because a coin is fair. If you're too high in one area, at some point, you're going to have a lot of tails up flips to make sure that that coin is in fact fair. Now, your book talks about an example of the 2014 World Cup, some of which I actually got to see. And Germany basically outscored Brazil 7-1. Now, generally, I don't really watch a lot of soccer. I watch a lot of hockey, and I would say also that it's very, very rare to get like 7 goals in a hockey game. So that's kind of rare. Now, that's really high, which means that odds are pretty good in the next game. Germany is not really going to get 7 goals. And it turns out that they didn't. In the finals against Argentina, which oddly enough, I watched in a Buffalo Wild Wings with a friend, the score was 1-0. So sometimes you're going to be really high, but that's because these things are kind of randomly determined. You have an average. So if you're high sometimes, eventually you are going to regress back toward that average. So for example, let's talk a little bit about the depression study. Now, generally, when people are picked for depression studies, they want to look, if we really want to show dramatic results with our intervention, we're going to select people on the basis of their pre-test scores. And we don't necessarily want somebody who is mildly depressed. We might want somebody who is more moderately depressed. The results will be far more interesting and far more dramatic if we can show that our intervention really helps boost depression in people who have moderate cases. So let's imagine that participants were selected on the basis of those pre-test scores. Here's what's really critical. So if you score very, very high on this depression inventory at pretest, regression of the mean suggests that your post-test score will probably be a little bit lower. Not necessarily because of spontaneous remission, not necessarily because the intervention worked, but because of regression to the mean. If you're high on one test, you have an average level of performance or an average level of depression. You might be high on that pretest, but that means you're going to be low on the pretest. So scores will likely be lower at that post-test because of regression to the mean, even if depression levels are still the same. So this is a case where, once again, we can't really be sure if the change in depression is because of the treatment itself or simply because of regression to the mean. So in our next lecture, we'll talk about different things that you can do to basically rule out the effect of regression.